Alright guys, so today we are looking at FSA Review Number 11. And for the following graphs, we need to find and label the x-intercept, the y-intercept, axis of symmetry, maximum, and minimum, and then state whether the function is increasing and or decreasing. Alright, so we are going to look at number 1. Alright, so number 1, so really quickly, I would define number 1 as a linear function. It is a straight line. It is also a decreasing function because it's going down from left to right. So the one way that I remember to read functions is, since we read a book from left to right, you also read anything in math and from left to right, so specifically a function. So this would be considered a decreasing function. So looking at this graph, let me zoom in a little bit. Alright, so looking at this graph, I think we can both agree that my x-intercept is right here. So my x-intercept, I would say, is at approximately 1.5, 0. And then, so that's my x-intercept. And then if I look here, my y-intercept, so where it crosses the y-axis, so that would be at 0, 3. So that's my y-intercept. So the one thing with linear functions do not have an axis of symmetry, and they do not have a maximum or minimum value unless there are certain constraints on the function. So for this function, all we can define is that it's linear, it is a decreasing function, that its x-intercept is at 1.50, and its y-intercept is at 0.3. Alright, so now I'm going to move over to number 2. So number 2, the first thing I need to find is an x-intercept. Well, one thing, any function that makes a u, whether it's upside down or right side up, is considered a quadratic function. So let's go ahead and look at x-intercepts. So with quadratic functions, they always have 2 x-intercepts. Well, not always, but majority of the time they're going to have 2 x-intercepts. So I have an x-intercept at -1, 0, and my second x-intercept is at 5, 0. So it crosses my y-axis at 0, 5. Okay, so my axis of symmetry, when you're dealing with quadratics, your axis of symmetry is where you can take and you can fold your parabola in half so it maps onto itself. So it's also where the vertex is located. So my axis of symmetry is going to be the line x is equal to 2. And then for a quadratic, since you have a vertex, you're going to have a minimum value or a maximum value. So for this quadratic, since it's going down, it's opening down, you're going to have a maximum value. And your maximum value is your vertex, which is at 2. And if we look here, 2, 9, it's also your turning point of your function. Alright, so now let's look at this is what we call an exponential function. So exponential functions will never have an x-intercept. They approach the x-intercept, x-axis, but they never cross the x-axis. So, but we do have a y-intercept. So I would say that our y-intercept is at 0, 2.5, because it looks like it's maybe in between 0 and 5. Maybe you can argue that your y-intercept is 0.2. Also, again, you don't have a maximum value and you don't have a minimum value. So, and this function is an increasing function because if you notice, if I go from left to right, so from left, it's going up. Now, if it was going down, it would be a decreasing function. All right, so let's look at number 4. So number 4, I have this table right here. So I need to identify the x-intercept, y-intercept, axis of symmetry, maximum, and minimum. Well, first I want to see what type of pattern I have here. So and if I look at the top, so this is a difference of 1. Alright, so here, -7 to get to -4, so that means I'm adding 3. -4 to get to -1, again, I am adding 3. -1 to 2, add 3, 2 to 5, add 3. So when you have a consistent change with your function, this is a linear function. So if you notice, I'm adding 3 each time. So the slope of my function is positive. So since I'm adding 3, that means it's an increasing function. All right, so to identify my x-intercept is where my y is going to equal 0. Well, if I look here, I don't see where y equals 0. But if I look where x is equal to 0, that's my y-intercept. So I can at least write my y-intercept down, which is 0, -1. So and then my x-intercept is going to be when y is equal to 0. So using this information, I can actually write the equation of my graph. So y is going to equal 3x minus 1. So I'm going to set this equal to 0. So 3x minus 1, so add 1. 1 equals 3x, divide 3. So my x-intercept is 1/3. So then I can write my x-intercept as 1/3, 0. All right, so let's look at number 5. So number 5, I've got consistently on top, I've got +1, +1, +1, +1, +1. All right, so then down here, 3 to get to 0 is a change in -3. Then this is -1. Then this is +1. Then this is +3. Then this is +5. Well, it's not consistent. But I do notice, if you notice, so 0, -1. But on either side, I've got -1, 0, 1, 0. So this is actually a quadratic function. And you can't really say where it's increasing or decreasing because quadratics will have points where they're increasing and then they go to a decreasing function. So now I need to look at my x-intercept. So my x-intercepts are when y is equal to 0. So I can pinpoint those. I've got -1, 0 and 1, 0. And then my y-intercept is when x equals 0, so that's at 0, -1. My axis of symmetry will be my vertex, which also conveniently is my y-intercept. So that's all the information we needed here. So then for questions 6 and 7, let me zoom out. So for questions 6 and 7, it asks you, table 4, circle 1 is a linear function and is a quadratic. So you guys can use this information to continue on with the FSA Review Number 11.